Miss Frida. The final law that I will be demonstrating today is Newton's third law of motion, which states that for every reaction, there is an equal and opposite reaction. This is the principle that sends rockets up to the moon. Wow, how cool is that? There are everyday examples that you may not even know that apply to Newton's third law. Now, I'm going to show you a few examples and an even fun experiment that kind of has to do with rockets, so stay tuned. For my first example, I will be using a basketball. What will happen if I bounce the basketball on the floor? Write your predictions on your chart in your science notebook to see what happens.
Okay, now that you've made your prediction, let's see what happens when we bounce the ball. Was your prediction correct? Write down what you saw on your science notebook.
So when I bounced the ball on the floor, it bounced right back up. So how does this apply to Newton's third law? Well, when you bounce a basketball, there's a downward force on the floor. This is the action. Then the floor reacts by pushing the ball with the same force but in the opposite direction. So when you pushed it down, then the ball went back up in the opposite direction. So together, the floor and the ball form what is called an action-reaction pair. And that is a part of Newton's third law of motion. The next example of Newton's third law of motion, I will be using a balloon. What I will do is I will blow the balloon up and hold it together. Now what I want you to do is tell me what you think is going to happen once I let that balloon go.
All right, now that you wrote your prediction, let's see what happens when my fingers let go of the balloon. Was your prediction correct? Write down what you saw in your notebook.
How does our balloon example apply to Newton's third law of motion? Well, when I released my fingers from the balloon, the air that I blew from the inside pushed out of the balloon. That is our action. The reaction is the balloon moves with the force in this opposite direction, creating another action-reaction pair. Rockets and jet engines work much like a balloon filled with air. So just like in the example, when I filled the balloon with air and held the neck closed and released it, the pressure pushed out. If you release the neck of the balloon, it acts like a hole with no surface area for pressure to act on. This is a result of the net force acting forward on the balloon, which is also known as a thrust. The balloon flies forward under the influence of the thrust, and the air coming out back of the balloon is the equal and opposite reaction to the thrust. So just like in this example you can see in the picture, the action is the air releasing and the reaction is the balloon flying everywhere. Much like the rocket, when we think about it, the rocket is similar because it is filled with pressurized gas, and the reaction is that it helps the rocket fly off.